Hello friends, welcome to Sunil Engineering Academy. This is Bharath. I am teaching mensurations in mathematics and today we are going to see quadrilaterals and circles. Remember friends, we are dealing with the mensurations of quadrilaterals and circles in which we are going to see the area, the perimeter and lengths of these quadrilaterals. We are going to see parallelogram, rectangle, square, rhombus and trapezium. We are also going to see circle and semicircle. First quadrilateral we are going to see is parallelogram. A quadrilateral whose opposite sides are parallel and equal. Whose opposite sides are parallel and equal. See friends, if here in parallelogram A, B, C, D, opposite sides are parallel and also equal. In the same way, AD is parallel to BC and also the lengths are equal. What is the area of parallelogram? Area is given by base, that is AB. If AB's length is B and height is given by H, if height is given by H, then the area of parallelogram is B into height, that is base into height. And we know the perimeter. The perimeter is nothing but sum of all the sides. Here the perimeter is AB plus BC plus CD plus AD. Or we can say that if we have this side as A, then B plus B plus A plus A, that is 2 times of A plus B. Let us see a quick level 1 problem. If base and height of the parallelogram is 10 centimeters and 5 centimeters, that is the base is 10 centimeters and the height is 5 centimeters respectively, then the area of the parallelogram is, the formula is given by area of parallelogram is nothing but just multiplying the base and height, that is base into height, that is 10 centimeters into 5 centimeters is equals to 50 centimeter square. If base and height are given, we can get the area. Can we find the perimeter? No friends, we can't find the perimeter unless the other side is given or the angle is given. See here, if in the question the other side of the parallelogram is given by, it is 6 centimeters. Okay, then we can find the perimeter. The perimeter is given by 2 into A plus B. 2 into 6 plus 10, 2 into 16, that is 32 centimeters. This rectangle and square is also a parallelogram as it satisfies the property of parallelogram, that is opposite sides are parallel and equal. If you see a rectangle, opposite sides are parallel and also equal. These opposite sides are parallel and also equal. These two opposite sides are parallel and equal. Even in the square, this property holds good. But in addition to the property of parallelogram, we can see this internal angle is 90 degrees. Even in square, these internal angles is equals to 90 degrees. The only difference between rectangle and square is that in square, all sides are equal. And if we come to the diagonal of rectangle, this diagonal is given by root of L square plus B square. Here in square, the diagonal is given by A root 2. Friends, we are dealing with mensurations. So here we stick only to area, perimeter and length of the sides. If you want to go in depth of triangles, quadrilaterals and other polygons, I am going to start a series in geometry. You can find it in the playlist or the link will be added in the below description box. You can follow and get benefited. We are going to see rhombus. If we see rhombus alone, we may not understand it at its fullest. So we are going to compare this rhombus with square so that we can understand clearly. Friends, unlike rectangle and square, square falls within the rectangle and this rectangle is also falls inside the parallelogram. See friends, square is also a rectangle and rectangle is also a parallelogram because rectangle and square satisfies the property of opposite sides are parallel. What is the property of parallelogram? Opposite sides are parallel equal. Whereas in rhombus, the opposite sides are not parallel, but all sides are equal. In rhombus, if we compare with the square, all sides are equal, and these sides need not, it's not compulsory or mandatory to be parallel. But if we take the diagonals D1 and D2, these diagonals bisect each other at 90 degrees angle, friends. These diagonals bisect each other at 90 degrees angle, and area of rhombus is given by, in the same fashion, half B into H, but here instead it is half D1 diagonal 1 multiplied by diagonal 2. The area of rhombus is half D1 into D2. We know that all sides are equal, so perimeter becomes, if one of the sides of the rhombus is A, then perimeter is equals to 4A. Okay friends, I hope you have clear with the differences between rhombus and square. Let us see a quick problem in rhombus. If the length of the diagonals of a rhombus is 16 centimeter and 12 centimeter, then find the side and area. If D1 is given by 12 centimeters and D2 is given by 16 centimeters, we know that these diagonals bisect each other, in the sense they cut at the midpoint of both the diagonals. Then this part becomes half of D2 and this part becomes half of D1. If we take BOC as a triangle, here D1, that is half of 12 centimeters. We are taking COB as triangle. COB. Here the base is given by half of D1, that is 6 centimeters, which is half of D1, and this part is given by half of D2, that is half of D2 is 16 by 2, that is 8 centimeters. We know these diagonals bisect at 90 degrees. At 90 degrees, this forms the right angle triangle. From this, the hypotenuse is given by Pythagoras theorem, 6 square plus 8 square, that is 100. 6 square 36 plus 8 square 64. 36 plus 64 is 100. We get root of 100, that is equals to 10 centimeters, which is nothing but one side of the right angle triangle. In the same way, if we get the side as 10 centimeters, in rhombus all the sides are equal, so the side is given by 10 centimeters. And area, we know the formula, half D1 into D2, that is half 12 into 16, half 12 into 16, which is nothing but 96 centimeter square. The side is 10 centimeters and area is 96 centimeter square. Trapezium. In trapezium, one of the opposite sides are parallel. Trapezium is also a quadrilateral in which one of the opposite sides are parallel. Here friends, AB and CD. AB and CD are parallel, and the area of trapezium is given by half into sum of the sides or sum of the lengths of parallel sides, that is A plus B into distance between these parallel sides, that is height, h. Or we can also say that the distance between this parallel side. So half A plus B into distance between this parallel side. Let us see a quick problem. If sum of the parallel sides of trapezium, if sum of the parallel sides of trapezium, here the parallel sides are AB and CD, and this sum of these lengths is given, and distance between them is given by 18 and 6. Then find the area. See friends, here sum of the parallel sides, that is A plus B, is given 18, and distance between them, that is H, is given, which H or D distance is given, which is 6 centimeters. Then find the area. We have seen that area of the trapezium is given by half into sum of the parallel sides into distance between them, or height. Here A plus B is directly given, which is nothing but 18 into distance is 6. 2 9s are 18, 6 9s are 54 square centimeters is the area of the trapezium. Let us see circles and semicircles. If a circle is given by radius r, then the area of the circle is given by pi r square, and circumference, which also known as perimeter, circumference of the circle is given by 2 pi r. The same way, if we come to semicircle, semi in the sense half of the circle. Semicircle means half of the circle. The area is also half of the whole circle, that is pi r square by 2. Pi r square by 2. In the same way, if you think that circumference of the circle is also half of the whole circle, then it is wrong, friends. The circumference of the semicircle is not half of the circumference of the whole circle. Instead, if you go by concept, circumference is nothing but perimeter, that is the length of the whole curve. This is given by 2 pi r, whereas half of the curve is given by 2 pi r by 2, that is pi r. But semicircle is an enclosed figure. You have to consider this radius and also this radius, that is 2 times the radius plus 2 r. So the circumference of the or perimeter of the semicircle is given by pi r plus r, that is pi r plus 2r, which is given by r into pi plus 2. Clear, friends? Welcome to icebreaker part of our video, friends. Here, this is the interesting part of our innovation of our videos. Here we are going to give you a lifesaver concepts which will be very useful in your examination. See friends, when you are writing an examination, it's not a classroom. There in classroom you can remember all the formulas, but in the examination hall you will be having so much of pressure, tension, and if you don't remember the quadrilateral formulas, then what you have to do, that I am going to discuss now. You always remember the area of the triangle, right angle triangle, half BH. Everyone remembers this. Am I right, friends? If the parallel sides of the trapezium and height is given, then if you want to find the area, what you are going to do? you are going to draw a trapezium and you are going to draw like this, and you can divide this trapezium into two triangles, friends. By this we can get the area of this triangle. You can get the area of this triangle, which is nothing but half base into height, and you can also find this area plus half a into h, which is nothing but half a plus b into h. This is how you are going to find the area of the trapezium. In the same way, if you got confused with the area of the parallelogram, then you can draw a line like this, and the same distance between the parallel lines exists here, and the opposite sides are equal in the parallelogram. This triangle's area is half BH, and this triangle's area is also half BH. Here half BH plus half BH becomes BH. In rhombus, unlike the derivation, you know the format of area of the right angle triangle, which is nothing but half BH. Here in rhombus, you are going to replace this B and H with the two diagonals, that is D1 into D2. Here the area of rhombus is half D1 into D2. That's it, friends. Is it not very easy? Please watch the video in geometry of quadrilaterals in which concepts were dealt in detail. Friends, this is just the mensuration of the quadrilaterals. Here we have dealt with the minimum concepts, but if you want to know more about quadrilaterals and its properties and some level 2 and level 3 problems, please go through the video. This link is given below in the description box.